All right, so for review 1.1, the first thing we're going to start off with is vocabulary. So number 1, it says a blank has neither size nor shape. That would be a point. A point has neither size nor shape. For number 2, a blank extends infinitely in 2 directions. That would be a line. A line extends in 2 directions, right? It goes both ways. A blank is a flat surface. There's your key right there. Surface means it's a plane. And then the blank of a segment is the point on the segment that divides it into 2 congruent segments. So the midpoint, because it cuts it into 2. All right, if we take a look at the next part, in number 5, we're asked to name a line that contains point A. So point A here is on this line right here. We can call that line L if we want, that cursive L. Or we can call it by any 2 points on that line. So we could call it AB. Remember, we put the line with the arrows on top. We could call it BA, right? We could reverse the order. We could call this BC or CB. I'm just giving you all your possibilities. I would only need one of these answers. Or AC or CA. Any one of those answers would be just fine. All right, what is another name for line M? Line M we see is the other line in the other direction. We have a few different possibilities there, this line right here. We could name it by its points, so we could call that BD or DB. We could switch the direction. Okay. All right, we want to name a point that is not on AC. So here's line AC, a point that's not on there. We could use point D, or we could use point E. Either one of those is not on that line. We want another name for line L. Really, any of these lines is another name for line L. Okay, so it could be AB, BA, any of the ones we had listed before. So AB, BA, BC, CB, and AC or CA. And then we want to name a point that is not on line L or line M. So it's not on either one of those. It's got to be point E. That's not on either one of those guys. All right, then we want to name 3 collinear points. So 3 points that are in a line. So that would be points A, B, and C. All right, so we want to draw and label a figure for each of these relationships. So in this one, it says ST, line ST, intersects with line AB at point P. So here's ST, and it's going to intersect, so it's going to cross with AB. And it's going to cross at point P. So there's more than one way to draw this, but something along these lines would be perfect. All right, the next one we're going to draw is that point X is collinear with points A and P. So that means all of them are on a line. We could have A, X, and then P. We could have, whoops, that's not really lined up. We could have AP and then the X. They just all have to be in the same line. Line L contains points X and Y. So I just need a line. We're going to call it L, so cursive. And then point X and point Y have to be on it. All right, in number 14, we want to find the length of LO if M, of segment LO, if M is between L and O. We don't know that it's the midpoint, we just know it's in between. So here's L, here's O, M is somewhere in there. It's not necessarily a midpoint. Don't get that confused. All right, so we know that LM is 7x minus 9. We know that MO is 14. And we know that LO is 10x minus 7. LO. So 10x minus 7. Okay, so what we want to do here is make sure that we are piecing everything together. So the red plus the yellow, 7x minus 9, plus the yellow here, 14, is going to equal the entire blue part. So it's going to equal 10x minus 7. So we'll solve for x, and then we can plug that back in to find the length of LO. So that's 7x plus 5 is going to equal 10x minus 7. We can subtract the 7x and get a 3x on the left, or on the right. Add and get 12. So that means that x is going to equal 4. All right, so if we want LO, LO is 10x minus 7. So LO equals 10 times 4 minus 7, which is 40 minus 7, which means 33. So the measure of LO is 33. All right, number 15, very similarly, we're given some information. We want to find the value of x this time. We're told that RS, the entire thing, RS is 24. All right, we know that RT is 6x minus 4, and we know that TS is 10. All right, so if we add the two segments together, we know that they will equal the entire segment. So I can add the red part plus the green part. So we've got the red part, which is 6x minus 4, plus the green part, which is 10. It should equal the blue, which is the whole thing, 24. All right, so let's just combine this up. So that is 6x plus 6 is equal to 24. Subtract and get 6x equals 18, so x is 3. Okay. In number 16, we want to find both x and the measure of AC. So in order to find x, we're using kind of the same concept here. So we're going to add the smaller segments together, and they'll equal the larger segment. So we have the red segment, which is x, plus the blue segment, which is going to be 2x, is going to be equal to the entire segment, which is 2x plus 5. Okay, so that's going to give us 3x equals 2x plus 5. And when we subtract, x is equal to 5. All right, that's part of it. Then we want to find AC, which is this entire thing. So AC is going to equal 2 times x, which is 5 plus 5. So that's 10 plus 5, and we'll get that AC is 15. All right. In number 17, it says that if E is between A and B, so here is A and B, and E is somewhere in between, then we know that AE is 4x minus 12. We know that EB is 10x plus 30. And AB is 74. So the whole thing is 74. We want to find X, AE, and EB. Same concept. Add the smaller ones. They equal the larger one. So we've got 4x minus 12 plus 10x plus 30. And that's going to equal the entire thing of 74. Combine like terms. So we get 14x plus 18 is equal to 74. We'll subtract 18 from both sides, and we're going to get 14x is equal to 56, so x is 4. Okay, that's part of it. We also need AE. So that's 4 times 4 minus 12, or 16 minus 12, which means that AE equals 4. We also need EB. So that's 10 times 4 plus 30, which is 40 plus 30, which is going to equal 70 here. So EB is 70. All right, number 18. All right, so we want to find the distance between these points. We're going to use the distance formula. That's x1, y1. Whoops. x1, y1, x2, y2. So the distance formula is the square root of x1 plus, or x2 minus x1. So that's -4 minus -1 squared plus y2 minus y1. So 6 minus 2 squared. So we could just type that entire thing into the calculator, and that is going to give us D is equal to 5. All right, then we want to use the number line to find a few things here. So we want to find the length of BD. So B looks like it's at -7 and D is at -1. So BD is going to equal the absolute value of -7 minus -1, which is going to give us 6 for BD. AF, we've got -9 and 3. So again, absolute value of -9 minus 3. That's going to give us 12. And BG, so that's -7 and 8. Absolute value of -7 minus 8, that's going to give us 15. We want to know, is BC congruent to CD? BC we see is 3 units long. CD is also 3 units long. So the answer there is yes, because they are both 3 units long. In the next part, we want to find the coordinates of M, the midpoint of PQ for those points. So the midpoint formula, we just average the x's and average the y's. So again, remember the midpoint xy is going to equal x1 plus x2 over 2, comma y1 plus y2 over 2. So this is my x1 and my y1, my x2 and my y2. Okay, so that's going to give us 2 plus 6 over 2 and 5 plus 9 over 2, which means that is 8 over 2, which is 4, and 14 over 2, which is 7. So 4, 7 is the midpoint. Next, we want to find the coordinate D if E is the midpoint of CD. So E is the midpoint, okay? Here's CD. E is somewhere in the middle. All right, so C would be my x1, my y1. D would be my x2, my y2, remember my endpoints. And E would be my x and my y, my midpoint. Okay, so if my midpoint is x comma y, x1 plus x2 over 2, comma y1 plus y2 over 2. Okay, so the next thing we want to do here is to plug in what we know. So E is our midpoint. That really means, whoops, we'll get rid of the M. We have 0, 1 over here. And over here, my x1, x2. x1 is -3, but I don't know x2 over 2, comma 4 plus y2, which I don't know, over 2. All right, so now I can set up two separate equations really to solve for x2 and y2 here. So I can say 0 is equal to this x information. So 0 equals -3 plus x2 over 2. And I can also say that 1 is equal to this information. So 1 equals 4 plus y2 over 2. Okay, and we'll solve for both of those. So when I multiply by 2, I still have 0. So 0 equals -3 plus x2, which means x2 is equal to +3. Multiply, I get 2 is equal to 4 plus y2. Subtract, I get -2. So that means the point would be at 3, comma, -2. All right, so for the next part, we have that C. We want to know, is C the midpoint of AD? So here is A at -9. D is at -1. We want to know, is C the midpoint? I mean, we can pretty much just eyeball this and see that is not the midpoint of -4. But we could double check by saying -1 or -9 plus -1 divided by 2. That would be -5. So no, C is not the midpoint. Okay, next, find x that is 1/4 of the distance from A to F. So the first thing we want to do is figure out how long is AF. AF is going to equal the absolute value of -9 minus 3, which is +12. Then we want to go 1/4 of 12. So 1/4 of 12 is going to be 3. That means we need to move 3 units from A to F. 1, 2, 3. That puts us at -6. So x is at -6.